All right, hi, this is Mrs. Slater, and today we're going to be working with some formulas and some problem solving. And what I mean by formulas is that you're going to get R all by itself, and you're going to need quadratics to solve. So if you're going to get R by itself in the first one, you first want to divide both sides by pi. And then anytime you want to get R by itself and there's a square, we're going to take the square root of both sides. So R is going to be plus or minus. Don't forget when you divide by or take the square root, you're going to have to use plus or minus. And then you have the square root of a over pi. Do not worry about rationalizing the denominator for these particular problems. All right, on the next one, we have t we have to get by itself. So first I'm going to eliminate the fraction by multiplying t squared to both sides. Then dividing by k, we'll get t closer by itself. And then finally, we're going to take the square root of both sides. And again, plus or minus. Make sure you are putting the plus or minus on there. OK, the next one, solving for h. Quick step, take the square root of both sides. Don't forget the plus or minus. And then the last one, go ahead and push pause and see if you can solve that one on your own. Okay, so if you multiplied both sides by 2g and then took the square root, you are correct. Don't forget the plus or minus. And then actually a better way, a better algebraic way to write this would be plus or minus square root of 2hg. Okay, so that's formulas. Now for a couple of word problems. Finding the interest rate when $1,000 grows into $5,000 in 2 years compounded annually. So there's a few things that we got to know first. The formula itself is A equals P 1 plus R over N to the NT. Now, I want to go over what these all mean. A is going to be the end amount. In this case, it's going to be the end money amount. P is going to be the beginning amount. R is going to be the rate. N, in both cases, is going to be the number of times compounded per year. And then finally, the T is going to stand for time. Okay, so also in this, on the side here, compounded annually means that N is going to equal 1. If you're compounding your money monthly, then N is going to equal 12. And so on. If you're compounding quarterly, that would mean 4 times a year. So that's going to mean N is going to equal 4, and so on. Okay, so we have the interest rate. Let's go back to the problem now. Use our formula to begin. And we're going to insert all the necessary information that we have. $1,000 is growing. So that's going to be the beginning amount into 5,000. So that's going to be our ending amount. In 2 years would be the time. And compounding annually is just going to be 1. R is what we're trying to find. So that's going to be left open. Now how do we get R all by itself? Is by first dividing everything by 1,000. So now we're left with 5 equals 1 plus R to the second. A lot of simplifying, and it's going to make it a lot easier. Now just use your rules of square roots in order to solve. So if I take the square root of both sides, you end up with plus or minus square root of 5 and 1 plus R. And then R is going to equal, let me get some more room here, negative 1 plus or minus square root of 5, which is going to be R. Okay, so if you are solving for each one of them, we're going to find negative 1 plus square root of 5, and we're also going to find negative 1 minus square root of 5. Okay, you have 1.23 and a negative 3.23. So the interest rate, this would not be possible in order to get money to to have interest on it, that would not be possible. So that's going to be extraneous. And then the interest rate itself has to be 123%. Because whatever answer you have, you're going to write it as a percentage versus a decimal. Okay, so let's go on to the next one. A ladder of 20 feet long leans against a wall. The bottom of the ladder is 7 feet from the wall. And how much would the lower end of the ladder be pulled away so that the top end would be pulled down by 2 feet? Lots of information going on here, so let's draw a picture. So the first triangle, go ahead and push pause and draw that. We're going to find x by using Pythagorean theorem. So 7 squared plus x squared equals 25, and then x equals 24. Okay, so if that's 24 and the ladder is moved down 2 feet, that means this value right here is going to be 24 minus the 2. So this is going to be 25 feet. Okay, now if we know that this is a right triangle, then this information we'll be able to find out because Pythagorean theorem also will let us know that. So I'm going to call that y. Y squared equals 25 squared. And when you solve for y squared, you end up with y equaling 11.9. So just do the Pythagorean theorem to get that. And then if the whole thing is 11.9, then we know this distance right here, you can just subtract 11.9 minus 7. And you end up with 4.9 feet that the lower end of the ladder would be moving. Okay, so that's this distance right here. And the last example is about an object that's getting dropped from a balloon of a height of 500 meters. So from here to the ground is 500 meters. And the balloon is, or something from the balloon is getting dropped. And the formula for anything that's being dropped has to be used according to gravity. And in this one, for gravity, it's going to be 4.9 t squared plus velocity times t. T stands for time, S stands for the starting height, and then V sub O is considered the velocity. Okay, so the 4.9 is for gravity when you are dropping in meters per second. So that may change depending if you have feet or another unit of measure. So how long does it take to reach the ground? Well, S is going to be 500 since that is the starting height. 4.9 is a coefficient we're going to have to leave there. T we do not know because that's what we're trying to find. And velocity, if you are just taking an object and going straight down, you are not putting any more force than what gravity has on it. So that's going to be 0t, which is really nothing necessary that we're going to need here. So if you divide both sides by 4.9, you end up with 500 over 4.9. And then by taking the square root of both sides, you end up with t equaling 10.10 seconds. Now again, that's approximately, so I should write that in the work. So 10.10 seconds for an object to get dropped to the ground 500 meters. Okay, now what if there is actually somebody threw it to the ground and the initial velocity? So that means that this part right here is being thrown, not dropped. So we are going to use the same formula, 500 equals 4.9 t squared, but now the velocity is 12, so I have to insert a 12 in for V sub O. Okay, so we'll have to set it equal to 0 since we have t squared and t. Bring the 500 over, and then use the quadratic formula. So use the quadratic formula and see if you can get the time to equal 8.95 and 11.4 for each one of them, and then we'll check that one in class. Okay, so make sure you have that written down. Okay, and then the last one, how far will it fall in 5 seconds? Now I'm basing this off of part B. I'm going to go ahead and say that it's the one that's getting thrown, not the one that's getting dropped. So 0 equals 4.9 t squared plus 12 times t minus 500, and I'm going to go ahead and replace the 2 with everywhere. I didn't mean 2, I meant 5 seconds, because it's time with t is going to be replaced by 5. And go ahead and multiply all that together, and we'll check that in class as well. Okay, that concludes the lesson for today.